Okay. So this is actually a facility in southeast New Mexico. It's a gas separation plant. And right over here, you see a little white roof and a little something sticking out of the ground. That something is a carbon storage well. And there's actually two of them operating at this facility. This is at Red Hills right now, not doing enhanced oil recovery, but putting CO2 with a little bit of H2S into storage in saline aquifer. So usually when I'm talking about CO2 storage and also direct air capture, that's where you take CO2 from the atmosphere, do something with it to reduce the CO2 that's already there. The very first question that people ask me is why? Why would you want to do this? Why is this important? And if you weren't here yesterday, sorry, some of this is a slight repeat, but there are some things that are challenges to meeting climate goals. Those things are energy demand versus supply. We can't scale some things fast enough to replace other things as rapidly as we would like. There's critical building materials that emit CO2 while they're being made. There's strategic minerals that we rely on to be able to use our new technologies. And then there's politics. Different parts of the world have different priorities. If you're trying to develop your country's energy supply, it's different than if you have a lot of it. So I heard somebody say at a conference a couple of years ago that the best megawatt is a negawatt, right? So you reduce. So if you're in the US and you use 30 times as much energy as the average citizen of Ghana in Africa, it's easy for us to reduce, harder for them to reduce when they don't have enough already. And then there's two other categories. Then this comes around to direct air capture. There are going to be future unmitigated emissions from the developing world. This is something we don't have control over. We can only control what happens here. And then there's legacy emissions. Since the Industrial Revolution in 1750, roughly 1 trillion tons of CO2 have gone into the atmosphere. So on the left-hand side of this, you have the OECD countries. We're actually reducing slightly our dependence on hydrocarbons and dramatically in coal between now and 2050. But the rest of the world, where you have developing nations in South Asia, in Africa, in South America, they're growing those categories. That means you have to try and convince them to manage their emissions, and you have to do that by making it inexpensive and by giving them good alternatives. And then that's the geopolitical part, and then there's going to be some unmitigated emissions. So this is where direct air capture comes into play. We have to deal with not only our own carbon emissions, but we have to potentially deal with other people's carbon emissions. Okay. This is just the legacy emissions. The US by far, just over 400 billion tons of CO2 emitted since our industrial revolution. China is behind us, but not for long. They'll catch us and pass us here in the next decade or so. And it's important to consider that a CO2 molecule, I just breathed out some CO2 molecules, they can stay in the atmosphere for 990 years on average, right? Kind of a fun fact. 8 billion people on the planet breathe out 3 billion tons of CO2 a year. All right, so how do we effectively reduce atmospheric carbon? It's a really big challenge. You have a bunch of the power, 52% of the world's power comes from coal or natural gas. You have vehicle fuel at 9%, critical building materials like cement, steel, and glass, almost another 20% of emissions. And the strategic minerals can be scarce. So some of those things are going to be hard to mitigate. You may get to a point where you can supplant coal, for example, in the United States, but it's still going to be used in other places. So that means you have to figure out a way to mitigate those emissions. And the way that we mitigate them is by capturing and then storing them. And that buys us time for other technologies to come into place, for new materials to be discovered, and for infrastructure to be built up. And we also need to manage legacy CO2 that's already been emitted, potentially. So reduce the atmospheric burden right now. another thing that's happened since that industrial revolution, we've essentially doubled the amount of CO2 in the atmosphere. Now, it's still a small fraction of percent, but it's hard to imagine a scenario where that doesn't have some kind of an impact. And IEA, GHG, COP, all those people, they're telling us that we should be storing 6 to 8 million tons of gigatons a year starting a couple of years ago. So we're already a little bit behind the curve. So in the US, we are actually kind of at the front in the world on carbon storage. In 2019, the US Department of Energy divided the country up into 4 regions. These are to commercialize projects using technologies that have been developed over the last 3 decades of research at the Department of Energy. We're fortunate in New Mexico Tech to have the Carbon Utilization and Storage Partnership of the Western US. We have 14 states, about 20 organizations in those states, state surveys, universities, research centers, and around 200 scientists that are working and collaborating on a lot of projects. This map shows sources. So the circles, the bigger they are, the darker they are, the larger the CO2 associated with them. The largest one left in New Mexico is the Four Corners Power Plant, emits about 10 million tons a year of CO2. But there really are CO2 point sources everywhere. And anywhere you have a point source of carbon, you can capture it right there and then put it into storage. Where you don't have point sources and where you have cars driving around and people burning natural gas in their houses, then you have to worry about trying to capture from the atmosphere. And that's where DAC comes into play. So New Mexico is actually at a bullseye. So Biogen is, excuse me, a transport expert. And these are blue lines are CO2 pipelines. Some of those have been around since the 60s, and they mainly feed enhanced oil recovery projects in the Permian Basin. Enhanced oil recovery, you put CO2 in the ground, it chemically reacts with the oil, makes it easier to come out. But over long periods of time, most of that CO2 stays in the ground. So it is a form of storage. But we have that. And then the blue squares are CO2 storage projects in the region and the area. And again, most of those are right here too. And I'm not going to go into the details of it, but of the 6.75 million tons of CO2 that was stored in the US last year, I'm sorry, of all the CO2 that was stored in the US last year, 6.75 million tons of it was done essentially in New Mexico and West Texas, and represents 75% of the CO2 that's captured. So if you do the math, we're at about 1% of where we need to be. So that needs to accelerate. The Carbon Utilization and Storage Partnership has built up a portfolio of about almost 40 projects. So this is really happening. And places like Red Hills, where Matt has done some work, are important places to show this technology is very effective. I think Matt said yesterday that facility captures 99.98% of the CO2 that comes to it and puts it in the ground. That's pretty good. Okay, so we have 3 brilliant scientists and then Matt. So the scientists are going to dazzle you with their brilliance in capture, in transport, and in storage. And then Matt's going to pull it all together because he's actually doing it right now at a commercial scale. So very important stuff.